This lesson's about enzymes and how temperature and pH can affect the rate of enzyme-catalyzed reactions. So first, let's remember that we've already looked at how the substrate concentration can affect the rate of reaction. We've seen that as you increase the substrate concentration, the rate of the reaction will increase until it plateaus. So you'll see something like that. Also remember that each point on this graph, where the y values are the rate of reaction, is actually the slope of a different graph, where let's say this is the concentration of the product, and here we've got time. Then as time progresses and we see more product building up, the slope of this graph, the rise over the run of this graph, becomes the y value on this graph, because the slope of this graph is the rate. So now let's look at the effect of temperature and pH. We'll have those as our independent variable, and rate of reaction will be our dependent variable. So when we consider temperature, we need to think about collisions, because remember that for a reaction to happen, the substrate needs to effectively collide with the enzyme. This Pac-Man here is my enzyme, and this pie shape is my substrate, and the substrate has to collide with the active site of the enzyme in order for the reaction to progress. And so collisions are really at the center of enzyme-catalyzed reactions. Well, we can increase the rate of collisions by increasing the temperature, because increasing the temperature increases molecular motion. Temperature is just a reflection of the average kinetic energy of all the molecules, or the average energy of motion of all the molecules. So increasing the temperature increases molecular motion, and therefore will increase collisions between the substrate and the active site. And so as you increase temperature, you see an increase in collisions, which I'm reflecting with this dotted line. So we see an increase in collisions, and because that means we see more contacts between the substrate and the active site, that's going to increase the rate of the reaction. But increasing molecular motion at a certain point will also denature the protein. Remember that denaturation is a change in three-dimensional shape or conformation, and therefore function of a protein. And as we increase the temperature, we increase the molecular motion. That affects the enzyme itself, and at a certain point the bonds holding it together start to get disrupted. So if we then imagine that denaturation is increasing as temperature goes up, and therefore we're seeing a decrease in the total number of enzymes that are functional, which decreases the rate of reaction, we get a drop-off like this. Again, this is because of denaturation. Putting those two things together, the overall effect is that as temperature increases, we first see an increase in the rate of reaction as a result of increased collisions between the substrate and the active site, and then after a peak, we see a decrease in the rate of reaction as a result of increased denaturation of the enzymes. The result of these competing processes of collisions and denaturation is that enzymes have an optimal temperature at which they're most active. For example, most enzymes in the human body are most effective around body temperature of about 37 degrees Celsius. So that's how temperature affects rate of reaction. Let's look at pH. Just like there is an optimal temperature at which enzymes are most effective, there are optimal pHs as well. And again, this has to do with the fact that the chemical environment of an enzyme affects its three-dimensional shape. So one enzyme might be most effective at a particular pH, whereas another one is most effective at a higher pH. And these can be seen to correspond to the environments in which they normally exist. For example, an enzyme in the small intestine where the pH is higher will have evolved to have a higher optimal pH, whereas an enzyme that's located in the stomach where the pH is lower will have evolved to have a lower optimal pH. And again, this all has to do with the 3D shape of the enzyme. The enzyme operating in the stomach will maintain its three-dimensional structure and therefore its function at the pH in the stomach, and the one in the small intestine will do it at that pH. So that's an introduction to the effects of temperature and pH on enzyme activity.